So again, looking at this from the last two lessons, making a decision, we can either reject the null hypothesis, and that's if this test stat is in the rejection region, or we do not reject the null hypothesis if it's in the non-rejection region. So not is non for this, it's not opposite. And remember, this is always, when you make a decision, it's always rejecting or not rejecting the null hypothesis. Then from that decision, we write a sentence. This word at the end is always claim. And then all of this that's highlighted is always going to be the same. So your sentence is always going to be there is or there is not enough evidence to. You're either going to have the word reject or support. If the claim is the null hypothesis, the statistical evidence that we find can only be used. So if the claim is the null hypothesis, we can only use the statistical evidence to reject the claim. And again, that last sentence is always claim, or that last word. If the claim is the alternative hypothesis, I put the comma in the wrong spot, statistical evidence can only be used to support the claim. So if the alternate hypothesis is the claim, this sentence is going to have the word support in it. If the null hypothesis is going to be the claim, then that sentence is going to have the word reject in it. For your decision, which I forgot to write that in this table, if our decision is to reject the null hypothesis, we don't have the word not, but if we do not reject the null hypothesis, our sentence has to have the word not in it. Oops. So maybe with that a little bit neater, it makes a little bit more sense. But you can always print that out and cut that out or rewrite it neatly if you want to. But remember, if your decision, if it's in the non-rejection region, you do not reject the null hypothesis. If you do not reject the null hypothesis, there is not enough evidence. The word, if the claim is the null hypothesis, you always reject. Claim is the alternate hypothesis, you always support. So now I'll flip back to this one. If you have it printed out, it's easier. So now we're going to look for a z-test for a mean. Just like chapter 6, we're going to have z's and t's. Chapter 8, we're going to have z's and t's. So there's two different methods for these. We're going to learn a rejection region today. The next time we meet, p-value. Then we're going to do it with t for rejection region and t for p-value. So a z-test for the mean when the population standard deviation is known. Just like chapter 6, when we use a z-test, the population standard deviation is known. We don't want to write that word over and over again, so we use the sigma notation. If we know the population standard deviation, then it is a z. Section 8.3, we will not know the population standard deviation, so we use t. So we verify the population standard deviation is known. That's the most important part in the sentence. The sample is random, which it will be. If you took AP Stat or if you take like a higher level stat class, that you'll have to test that. But for us, it'll always be true, and the population is normally distributed, or n is greater than or equal to 30. Don't worry about that part of the sentence. I wanted to put that in there to make sure you knew that that is true. But for us, we just need to know that the population standard deviation is known. State the hypotheses and label the claim just like yesterday. So I'm going to go through example 1 doing those steps that we did yesterday. In Pennsylvania, the average IQ score is 104.2. That's going to be the population mean. The variable is normally distributed. We have to be told that. And the population standard deviation is 15. I'm getting it. Call. Sorry. So my the population mean is 104.2. And the population standard deviation is 15. A school superintendent claims that the students in her school have an average IQ higher than the average of 104.2. So usually you can just start off writing H sub 0 and H sub A. And again, you can use H sub A or H sub 1 if you talk to Mrs. Moore or one of her students. They'll write H sub 1 probably. You can use it interchangeably though. So that purple stuff that I have written is always going to be the same for all the problems, the way we started off. So the superintendent claims that the students in her school have an IQ higher than average. So higher than average is 104.2, and that one's the claim. Because it says she claims have higher than average. So that one's going to be the claim. She selects a random sample of 30 students. And the mean of the test scores is 106.4. So from that sample, the mean is 106.4. So we need to be really diligent with our notation. X bar is the sample mean. Test the claim at alpha is equal to 0.5. 0.05. So we don't need to write all of that red stuff down, but I like to write it because it makes it so much easier when I go to do the rest of the problem. Believe me, students do better when you write it down. Not saying that you can't do well if you don't write it down. So that's the first two steps. We stated the hypotheses and labeled the claim. I also list out all my values. We're going to find the critical values now. To find the critical value, it's based on the region alpha, and we use the inverse norm. If it's a two-tailed test, we use alpha. I'm sorry, one-tail test. So if it's a left tail, or if it's a right tail, we do the inverse norm. If it's a two-tail, oops, sorry, and we label that as Z sub C. Or like I said the other day, some books write Z sub 0. If it's a two-tailed test, then we do the inverse norm of alpha over 2 because like the confidence intervals. And unlike confidence intervals, Z was always positive. Z sub C was always positive. So for confidence intervals, Z sub C was always positive. That is not true for chapter 8 with hypothesis tests. Z can either be positive or negative. So we know how to do all of that. The first problem is going to take the longest. Oh, sorry. So we find the critical values and the rejection regions. So I know this is greater than, it's going to be a right tail test. If you want to mark the mean as 0, you can. And alpha is 0.05. Since it's a right tail test, Z sub C is going to be positive. So to find Z sub C, we're going to do the inverse norm of 0.05. If you do the inverse norm of 0.05, you get out negative 1.64. But for this problem, it's a right tail test. It has to be positive 1.64. Remember that the normal distribution is symmetric about the mean. If 0.05 gives negative 1.64, it'll get positive for the other side. So we have our critical value. The way your quizzes are going to be set up is it's going to say critical value and then test statistic. So we stated the hypotheses, labeled the claim, drew the sampling distribution, and then we compute the test value. What's good about this, and you don't have to memorize anyway because you have your notes, the test value is just Z, is the mean minus the mean, the sample mean minus the mean, over the population standard deviation divided by the square root of n. You used that formula before. And we either call it the test value or the test statistic. A lot of times I'll just say value because I always stutter on test statistic. So to find the test statistic, Z is, and we use that formula. And that was step 4. So just to pause for a minute, step 1 was to find the population standard deviation. Step 2 was to state the labels or state the hypotheses and label the claim. Step 3 was to draw the sampling distribution and find the rejection region and the critical based on the critical value. Step 4 was to find the test statistic. Step 5, we make a decision. If the test stat is in the rejection region, then you reject the null hypothesis. If it's not, then you do not reject the null hypothesis. So our test stat is 0.8033. I don't know where it is exactly. So that test stat is about here. It doesn't matter where it is. You just want to know, is it less than 1.64 or greater than 1.64? Since it's less than 1.64, it falls in the non-rejection region. So step 5 is we do not reject the null hypothesis because it falls in that non-rejection region. Step 5 is we do not reject the null hypothesis. And lastly, our statement, step 6, is there is, you have to use the word not, enough evidence so it's in the non-rejection region. We do not reject the null hypothesis. There is not enough evidence to blank the claim. Because that alternate hypothesis is the claim, the word there is going to be support. Does anyone have any problems so far? All right, we'll go through the same thing for number 2. It's the same steps, obviously, but it should like come together in this one, especially if you have those papers. And I copied it wrong. I'm sorry about that. Or uploaded it wrong. So mine's going to be separate on, it's going to look like one piece of paper, but it'll be 2. So a researcher claims the mean cost of raising a child from birth to age 2 by husband-wife families in the U.S. is blank. I'm going to start off, I forgot for the last one. We should always start off like that. Every problem, no matter what. So a researcher claims the mean cost is that. So that means the alternate hypothesis is not equal to. So the researcher claims that it is that. A random sample of 500 children has a mean cost of $13,725. So the sample mean is that. Assume the population standard deviation is 2345. So that's my step 1. At alpha is 0.10, is there enough evidence to reject the claim? Sometimes we're given this part of it. So this part of the sentence, having the word reject in there, solidifies the fact that the null hypothesis is the claim. If it had the word support in there, then the alternate hypothesis would be the claim. But since it says reject, the null hypothesis has to be the claim. So that's steps 1 and 2. That's what we did before. Step 3 is to draw the sampling distribution like this. It's a two-tailed test. So I'm splitting alpha by 2. So to find those critical values, you do the inverse norm of 0.05. Then we need to find the test statistic, which is the 4th step. So the test statistic is the formula that we used before. The sample mean. Just got a coffee delivery. You're the best. Love you too. The sample mean, and we just use Z also to point out. think I mentioned it before, but I might not have. The critical value is Z sub C. The test stat is just Z. So it's the sample mean minus the population mean over the population standard deviation divided by the square root of the sample size. So you can do all that and you get negative 1.19. So I don't want to go through this too fast. For step 3, remember we found the critical values. And that shaded part was the rejection region. The shaded part is the rejection region. We found the critical value. And then step 4 is the test statistic. So eventually on your review, it'll be set up the way your test is set up. So you're going to have to state the hypotheses and label the claim like we did in the beginning. That stuff here, if you want to write it, you can write it. I personally would, because if you mess up that part and I see that you messed up there and carry on the mistake later on, then I'll see where you messed up. So you don't have to write it. And then there's going to be a line for critical value and there's going to be a line for test statistic. If you switch those up, you will get marked off a lot of points, especially because you have your notes in front of you. If you didn't, I would be more lenient, but you have your notes in front of you. So your critical value is Z sub C. That's what you find with the inverse norm. Your test statistic is what you find with the formula. So that is the new part of it. Step 5 is the part from the last couple days. We see where that test stat falls. So that test stat is negative 1.19. Negative 1.19 is on the negative side, and it's not quite negative 1.64. Doesn't really matter where on that line we graph it, as long as it's to the left of 0, but to the right of Z sub C. So again, it's in the non-rejection region, so our decision is to not reject the null hypothesis. You can write DNR or you can write do not reject, like I did up there. So your sample stat is in the non-rejection region, so you do not reject the null hypothesis, and your sentence is going to have the word not in it. So step 5 or 6 is there is not enough evidence to reject the claim. So there is not enough evidence to reject the claim. We use the word not because our decision was not. The test stat fell in the non-rejection region. All the nots go with each other. The null hypothesis is the claim, And also, the sentence said the word reject in it. So the conclusion has to have the word reject in it. Step 5 is the decision, and step 6 is the conclusion.